to show you how to simplify expressions by factorizing them. And before we get started here, just a refresher here on cross-canceling. And I just kind of wrote this down here. For example, this expression right here, I can cross-cancel these x's because these are factors. This is x times this. There's a little invisible times sign right there. So these two guys are factors. Therefore, I can cross-cancel these two x's. And why? Because x over x is going to equal 1 as long as x doesn't equal 0. And if I divide something by 1, it doesn't change. I cannot cross-cancel when it looks like this because these x's here are not factors. So this is pretty important before we begin. Okay, just the concept of cross-canceling. What it means is that we're just dividing it by 1, so it's not changing the value of the expression at all. Okay, so let's look at our first example here. Okay, like I stated earlier, we don't want to cross-cancel those p's just yet. It's tempting, but they're not factors, so we can't do anything. So I look at the top part of the fraction, and I look for common factors, which is kind of easy to see. I see a 5 is a common factor of that top expression, so I factorize that out. And 5 times 3p gives me that 15p, and 5 times 5 gives me that 25. And what's left on the bottom is just 5p. Okay? And now what I look for is anything to cross-cancel on the numerator and the denominator. And it looks like, since these guys are the same, 5 and 5, I can cross-cancel those because 5 over 5 equals 1. Rewrite my expression, 3p plus 5. And now I just have p on the bottom. And I cannot cross-cancel those p's because they're not factors. These guys are connected by plus there. So that's my final expression right there. Okay, let's look at another example. Similar to the top one, I have a common factor in the top expression, which I'll factorize out. I can see it. It's x. X is a common factor. So I pull that out of the expression. That's the highest common factor. X times what is 8x squared? 8x. And then x times what is that negative x? So that's minus 1. Okay. And this is all over 7x. Nothing can happen downstairs because it's just one thing. It's just one term, 7x. So now I look and I can see cross-canceling. And don't do these guys, but these guys, because those are the factors right there. And rewrite our expression as 8x minus 1 over 7. You don't need those brackets anymore because the fraction bar acts as a grouping symbol in itself. If you put those brackets there, it's not. Okay, let's keep on moving. Okay, this one looks a little bit harder, but it's not too bad. This top expression, what I have is I have a quadratic, and I have to factorize that. That's going to factorize into 2 brackets instead of just 1. And how I do what those 2 brackets are, how I figure it out, is I play that game where I think of 2 numbers that multiply to get 6 and add to get positive 5. Multiply to get 6 and add to get positive 5. And those 2 numbers are going to be positive 3 and positive 2. And so the rest of the expression goes in there. This is x plus 3 times x plus 2 would give me this expression here. Now I factorize the bottom. 5 is a common factor of the bottom. And when I factorize that out, 5 times x is 5x, and 5 times positive 2 is 10. And I can see those common factors. Instead of it being an x or a 5, a common factor can be a binomial. It can be x plus 2. All right, just because it has 2 things in there, it doesn't mean it's not a factor. We can cross-cancel those factors right there and rewrite my expression as x plus 3 over 5. Okay, so that one was a bit different because that's a quadratic, but if you know how to factorize those, the common factor should be visible, otherwise it wouldn't factorize. Okay, next example, factorizing this, and I've got 2 quadratics that I need to factorize. So no common factors going on anywhere in the picture yet. So I look at the top part, and I factorize that, and I say, what 2 numbers multiply to get negative 24 and add to get negative 5? So 2 numbers whose product is negative 24 and whose sum is negative 5. So set it up for two brackets over here. And think of those two numbers, which would be -8 and +3. Put the x's in there. And do the same thing for the bottom expression. Two numbers that add to get +2 and multiply to get -3. What would that be? +3 and -1. Did you get that? Okay. 3 times -1 is -3, and 3 plus -1, or 3 minus 1, whatever you want to say, is +2. So I write my expressions in there. I see the common factor. In this case, it's x plus 3. Cross-cancel those, and rewrite your expression as x minus 8 over x minus 1. And don't do something foolish like cross-cancel those x's after you've done all this hard work. Okay, the next example, it's going to look really hard, but I'll show you a couple of clues to make it easier. Okay, so I've got this really beefy looking expression here, and just take it one step at a time. Look at the top expression and think, okay, 2, 16, 14. I've got a common factor of 2 in each of those terms, so I can definitely factorize that out. I can factorize that 2 out and get n squared plus 8n plus 7. That makes things a little bit easier. And I can do the same for that bottom expression. I've got a 3, 18, and 15. What goes into all of those? A 3. So before you do anything, see if there's a common factor within all the terms. I'm going to get n squared plus 6n plus 5. Now, see if you can factorize this quadratic expression here like this with the two brackets thing. All right, I set it up because these two are both going to factorize into two brackets. Think of two numbers that multiply to get 7 and add to get 8. That's going to be 7 and 1. Finish the rest of that. X plus 7 and x plus 1. And do the same thing down here. Multiply to get 5 and add to get +6. That's going to be +5 and +1. And finish the expression there. And look to see what your common factors are. Not a 2, not x plus 7, but x plus 1. Quite easy to see. And now we can rewrite our expression. And if we can leave it like that. If we want to make it cleaner with no brackets in the final answer, we can expand that 2 through and get 2x plus 14 and 3x plus 15. Okay, I guess either one of those are okay because there's no more common factors left. It's a simplified expression. Okay, so these are just some examples. There's a lot more, obviously, but hopefully this gives you some idea of how to work these out. Okay, here's some practice problems for you to do. And when you see them, just press pause and the answers will come up shortly.